Lesson 12. This is our review day for test number 1. I'm going to go over the basic information that's on this page, as well as the activity interpreting graphs using calculus part 2, which is just a little bit later on in this packet. That's what I'm going to be doing in this video. Subject areas for the test. The focuses are functions and models, notation, terminology, sketching and interpreting graphs, as well as limits, and of course, our newest best friend, derivatives. The types of functions that we reviewed this semester included linear, polynomial, power, and rational. For each of those, I'd like you to be able to distinguish, work with, and write formulas for. I also want you to be able to solve equations in different formats. For limits, you should be able to evaluate them. You should be able to determine whether or not they exist. You should be able to look at end behavior to figure out the values of a limit that I ask you about. You should also be able to estimate some limits numerically, meaning with a table of values. Continuity, I want you to know when a function is continuous, and I want you to know the definition of continuous at a point. Derivatives, this is a bunch of what we've done this semester. You should be able to find a derivative at a point and a derivative function numerically. That means using a table of values. Graphically, that means using a given graph of a function. And then algebraically, which is the lengthy limit definition. And then I also want you to be able to use our rules. These are also called algebraic ways to think about the derivative. We had power rule, product rule, quotient rule, sum and difference rules, just the rules that we've covered so far. There are more coming, but not on this test. You should be able to interpret first and second derivative, including figuring out units for those two quantities. And I want you to understand what the sign of the derivative has to do with the behavior of the original function. That means increasing, decreasing, as well as concave up and concave down. You should be able to relate derivatives to graphs. I want you to understand second derivatives, and I want you to be able to look at a graph and decide whether or not the function is differentiable at given points. Applications of the derivative, we talked about local and global extrema using both the first and second derivative tests. You should know how to use both, even though they give you the same information. Optimization and modeling. There's a much more detailed list in the study guide below. It's actually not on this page, but it's a few pages down the way in the packet. For each item in that list, try to figure out what kinds of questions I might ask that are related to that item, and make sure you know the process for answering those kinds of questions. Let's look at this item from the study guide to see what I mean. So this is just one thing in the long list that's a few pages away in this packet. I want you to be able to find values of constants that make piecewise defined functions continuous. So if you don't know what that means, then this is an opportunity as you're studying for you to figure out what kinds of problems is Ian talking about here. You go back in the notes, you try to find something either in the homework or in this packet right here that is an example of this kind of a skill. And if you struggle, if you can't figure out what I'm talking about here, just ask me, right? And I'll tell you, I'll give you an example of a problem that fits the bill here. So I will pause the video here. I'm going to go find the one that is in my mind for this one and tell you where it is. Okay, so I found the problem I was looking for. It was in the activity back on lesson number 3, which is where we did continuity. And so here's the specific example from that activity. It said, find the values of k that will make this function continuous on all real numbers. And this was a piecewise function. I just grabbed a screenshot of it, so it includes my solution from that day. But this is the kind of problem that I want you thinking about, and I want you to be able to do. And that's what I mean when I say you should be able to find values of constants that make piecewise defined functions continuous. So I encourage you strongly to go through that study guide. I think some students miss out on an opportunity to ensure that they know exactly what they are responsible for on the test, and to make new connections and make sure that you know what you need to know. Okay, some things to know about the test. You can use a one-page front and back sheet of notes on the test of your own creation. You can write anything you want on that piece of paper, including formulas and practice problems worked all the way out with complete solutions. I think that it's important to take your time making that one-page cheat sheet, so to speak. I think it's an important part of a healthy study plan. Some students really take good advantage of this cheat sheet, and other students just, 5 minutes before the test, they write something scribbled out on the paper, and invariably those are the students that say, to me after the test, oh, Ian, I wish I had written down blank and it just wasn't on my cheat sheet. So take your time making a very good cheat sheet. You will find that it helps you, and possibly you won't even need it, because making the cheat sheet really solidifies what you need to know, and you actually won't need to even use it as a reference during the test. You should save the sheet after you take the test and bring it with you to the final exam. You can't use your textbook or any other notes. You may only use a scientific calculator, not a graphing one. Hopefully we can find some to lend you if you don't have one of your own. The test is intended to be a 1-hour test, but anybody can have 2 hours to take the test. I'm not going to write a particular window of time in here, but I will let you know exactly what that window is for your class. And if you have accommodations providing for extra time, please contact me as soon as possible. I encourage you to show all work on the test. The more you can clearly demonstrate your understanding of the material, the better your chances for partial credit. There's no formal homework assignment for next class, but for sure you should be doing a lot of studying. There is an assignment due at the start of the class after the test. It's a reading assignment, so hopefully you've been keeping up with your reading, but after you take the test, do that reading right there. So for the activities for today, you should probably first go back to class number 10, the long activity with parts A through X, interpreting graphs using calculus. We skipped a bunch of problems on that day because we didn't know second derivatives yet, but now we do. So I encourage you to go back and finish those. I did make, in the one video on class number 10, the activity video, I went through the entire activity. I didn't skip any of them. So if you get stuck, go back to the class 10 activity video and you'll find me working through all of the problems for this activity. In the next couple of pages, we'll find this part 2 of the graphs using calculus activity. That's what I'm going to go over in the rest of this video. There's also a sample test a few pages later in this packet, and each of those problems has a video up on YouTube of either me or one of my colleagues solving that problem step by step. Okay, so we're going to start this activity right here. We have a graph given that is f prime. Note this is not the graph of f. This should look really familiar. This is exactly the same picture as the long activity we had way back when in class number 10. And the only change I made is that it used to be called y equals f of x, but now it's called y equals f prime of x. I'm getting a lot of mileage out of this graph. So here are the questions we're going to answer. A lot of them are identical to the ones you answered in the other activity, but now the answers are going to change dramatically because the graph we are given here is f prime and not f. So let's give this a shot. We'll try to squeeze our answers in here. Okay, part A, where is f of x equal to 0? So I'm given the graph of f prime. F of x, I can tell you where f of x is increasing or where it's decreasing. I can tell you where f is concave up or concave down, but I can't tell you any specific f values. I can't tell you any specific output values for the function f. Just don't have enough information. The graph of f prime is not going to cut it for me. Okay, where is f increasing? I'm going to translate that to say where is f prime positive. And where f prime is positive is something we can hopefully read off of the graph. F prime is negative. This is the graph of f prime, so we're just looking at output values. F prime is negative until we get to A, and then f prime is positive all the way here, still positive until we get to C. Don't get distracted about where f prime, that's this graph we're looking at, is increasing or decreasing. Just thinking about where f prime is positive, just output values being positive. Okay, and then f prime is negative, output values there to there to there, and then it's 0 for just one moment in time, and then negative again, and then f prime is positive starting at I and going the rest of the way. So let's answer this question here. Where is f prime, where is f increasing? That was where f prime was positive, which is all the green intervals that I've got here from, from A to C, union, and then it starts at, it looks like I, and then it goes forever. I know sometimes I said you can put brackets. You could put brackets here because the question isn't about an inequality, although I wrote an inequality here. The question's about the word increasing. So it's okay to put square brackets there, but if the question had been this, then we would, in fact, right here, that's this question right here. We have to put parentheses in this question. We cannot put brackets. Okay, so where is f decreasing? That's just in the purple highlighted things on the graph. So that's from -infinity up to A. and then union C over to F. Got to be careful here. Is F decreasing at the point F? Well, you could make the case that it is. So in fact, I'm going to actually say that it goes right from C over to I. Totally okay to include the point F in there. It's also, you know what, that's actually inconsistent. If I'm going to include C, sorry, if I'm going to exclude C, then I should exclude F too. And then F to, what is it, I? Yeah. But if you had chosen to put brackets around all of these things up here, and you'd put brackets down here, and in fact, you wouldn't even stop the thing at F. You would just go from C directly to I with brackets around all of them. Full credit for the bracket answers or for my parentheses answers. Okay, just while it's up there, let's skip down to G, which says where is F prime positive? So I think we just did that. That's the same as our answer to B, from A to C, and then from I to infinity. Even if you use square brackets in part B, you must use open parentheses in part G, because this specifically says positive. You cannot argue that F prime is positive at A. F prime is exactly 0 at A, so you cannot include it in that question. Okay, so let's erase some of this stuff carefully here. And then let's take a look at part D. Where are the points of inflection of F? Okay, let's make our translating here. Points of inflection of F have to do with where F double prime changes sign. I'm going to simplify that a little bit and say it's where F double prime is 0. That's not 100% accurate, but for our purposes, it's probably good enough. So we're looking for places where F double prime is 0. I'm going to write this in kind of a funny way. F double prime is really the same as F prime prime. And F prime, this function in the parentheses, is the thing that is graphed over here, right? And so this question now, I have translated it to a point where it says, where is the function that's graphed? Where is its single first derivative equal to 0? So that's an easy question to answer, right? I'm just looking at this picture and I'm asking where its derivative is 0. That is to say where it has horizontal tangent lines. So the points of inflection of F are at those spots there where the tangent lines are horizontal. So let's get rid of all this highlighted stuff and answer now. Goodness, there's no room. I'll put it up here. So the places where this particular graph is flat are at B and D and F and H. Okay, bad news, gang. So let's take a look. Okay, I take that back. There's no bad news. Those are all for points of inflection of F. I was a little bit concerned with what I had said here with my half-truth, where I said that points of inflection correspond exactly to places where F double prime is 0. But I said in a previous class that points of inflection are specifically where F double prime changes sign. And so I just really needed to make sure that not just that F prime was 0, but that in fact the behavior of F prime was changing. And so increasing to decreasing, that's good. Decreasing to increasing, increasing to decreasing, and then decreasing to increasing. They're all points of inflection. I was worried about F, but it turns out it's fine. Okay, part E, identify the local extrema of F. Local extrema of F. So these are the highs and the lows of the original function F. And so that means we're looking for, what are we looking for? We're looking for places where F prime is 0, right? Like if I wanted to find local maxes and local mins of F, I would take its first derivative and set it equal to 0. And I can look at this picture and find places where F prime is 0. These are just the x-intercepts of the graph that's given. And so the x-intercepts of the graph that's given are A and C and F and I. Okay, but there actually is some bad news on this one. It's the bad news I was worried about on the previous question, but here it is rearing its ugly head. I actually don't think that F is a local extreme point of F. It's kind of confusing that it's the same letter, but I don't think that this point labeled F is a local max or a local min. So check this out. We saw earlier that the function F was, let's go up here. It was no, it started the decreasing. F was decreasing until we get to A, and then F is increasing just after A. And so I've got some function F, which is decreasing until A, and then increasing after it. So you bet that is a local extreme point. It's a min. And then let's take a look at what happens from near C. So F is increasing a little bit to the left of C and then decreasing a little bit to the right of C. Increasing to C, decreasing after, that means C is a local max. Ruby. Let's take a look at what happens for F. A little bit to the left of F, the function F is a decreasing function. And then a little bit to the right of the same point F, the function F is also decreasing. So that means that I've got some point F where the function is decreasing and then it's horizontal for a second, and I can't tell. It looks like maybe it's ready to turn around and start increasing, but it doesn't. It just continues to decrease. And that F is not a max or a min. And so we need to, sadly, remove F from the list of local extrema. It's really tricky, that one. But then I think point I is okay. So a little left of point I, F is decreasing, and a little right of point I, F is increasing. So decreasing to increasing means that I is a min. So I is good, but F is no good. Okay, part F now. Identify the global extrema of F on the interval from C to J. All right, let's highlight the interval from C to J. C over to J, everything in between. Okay, global extrema. So let's think very carefully about the information we're given here. I know that F is decreasing, starting at C and going out to F, and then it decreases again until we get to I. So from C all the way out to F with a brief hitch, but then it just keeps going until we get to I. Yeah, let me make my interval a little bit longer here. So it's supposed to go to J. So I know that from C all the way over to I, not quite to J, but all the way over to I know that my function F is decreasing. That is what we discovered right here, that F was decreasing. And then between I and J, from I forever actually, the function F is increasing. So I've got this function that starts, F starts to decrease at C, decrease, 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 until we get to the point I. Let's try that again. Decrease, decrease, decrease until we get to the point I, right below this point right here. And then increases kind of rapidly until I get to J, and then it continues to increase, but I'm stopping at J. So the question is, where are the global extrema of this function on the interval C to J? So it's decreasing, 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 and then increasing a little bit at the end. So where are the global extrema? Well, the potential global extrema are the endpoints there and over here, and also the critical point, which is right down there. So the highest point anywhere on this picture is for sure at the start, and the lowest point is this critical point right there at the bottom, which was at I. So I think those are our answers. Lots of analysis, very little writing. Let's see if we can squeeze this one in here. Global extrema. The max is at, where's the max? Is at the beginning, is at C, and the min is at the critical point, which is I. Okay, next up, we did G already, so let's take a look at H. Where is F prime equal to 0? Oh, thank goodness, an easy one. So F prime is just the function that's pictured. It's equal to 0 where we have x-intercepts. So that's just at A and C, F and I. Right, this is where the y values of F prime are equal to 0. Where is F prime increasing? Oh, another easy one, because we're looking at F prime. So we just have to read from the graph where F prime is increasing. So we're not going to do this one slowly, but F prime is increasing until we get to the top, and then increasing here, and then increasing there. So let's fill in. F prime is increasing from minus infinity up until the top, which is at B, and then union from D to F, and then union from the bottom, which is H, and then it looks like forever to the right. So F prime is increasing there. If you put brackets around those, that's fine, just not around the infinities. F prime is decreasing on the other intervals, so from B to D, and then F to H. Okay. Identify the local extrema of F prime. Oh, piece of cake. If they ask you about F prime, is easy in this particular case because we're looking at the graph of F prime. So the extrema of F prime are the highs and lows, the local highs and lows. So for example, there's a local max there and a local min there and a max there and a min there. So we're just going to write down those coordinates, local extrema. I'm not even going to distinguish the maxes and mins. I'll just list them. B, D, and F and H. Okay, how about points of inflection of F prime? Oh, easy again, because again, all we have to do is read off of the given graph. So points of inflection, looks like maybe at C, at E, at G. I think those are the places where the concavity changes, because it looks like from here until here, we're concave down, and then we change to concave up, and then we change to concave down, and then we change to concave up. And so I think we've got those 3 points that have purple arrows, C, E, and G. C, E, G. Okay, M. All right, so now we have to do some translating because this question, unfortunately, isn't about F prime, which is the graph we're given. Rather, it's about F double prime. So we translate. F double prime is the same thing as F prime prime. And so this question is really saying, where is the first derivative of the pictured graph, right? Because this F prime is the pictured graph. Where is the first derivative of the pictured graph equal to 0? So that's just at the local extrema, right? We've got places where this graph that's pictured is a local max or a local min. So it's just B and D, F and H. Okay, how do we read this? Oh, now we go to N to the right. Whereas F double prime positive, same kind of translation for this one. This is saying F prime prime is positive. And the thing in the parentheses, I've highlighted it before, that's the picture that we're looking at. So this is just saying, where is the first derivative of the pictured graph positive? And that is really the same as saying, where is this function increasing? Lots of mental gymnastics. We've done this before. Still can take your time. Pause this video if that's tricky. But the pictured graph having a positive first derivative means the pictured graph had better be increasing. And my goal with all of these questions is to get to a point where I have F prime, just F prime, not F double prime. Translate everything to F prime because that is the graph that I'm given. So where is F prime increasing? Well, we've actually answered this question already. It's right here in I. So I'm just going to copy that answer. So we'll put it up here, negative infinity to B, D to F, and H to infinity. Got that right? Okay, part O, we can do this one a little bit quicker here. Part O says where is F, part O, where is F double prime negative? That's just like this one over here. So instead of F prime being increasing, see if you get to a place where this translates to F prime decreasing. And F prime decreasing, I think, was one of our other answers. It's up here at J. So that's B to D union F to H. Not near enough space on this page. Okay, O, all right, now we're over to P. Where is F double prime increasing? Okay, more translating we have to do here. Okay, F double prime increasing means that its derivative is positive. If you tell me you have a function which is increasing, then that means that the derivative, the first derivative of that function is positive. Okay, this tells me that F triple prime is positive, and F triple prime on the previous activity, anytime I saw F triple prime, I said, I can't help you. I don't know anything about F triple prime because that's 3 levels away from the graph that was given, which was F. But F triple prime is really the same as F prime double prime. And I specifically wanted F prime in those parentheses because, again, F prime is the highlighted thing. It's the given graph. And so this is really saying that the second derivative of my given graph is positive, and if the second derivative of anything is positive, then that anything is concave up. And so this question with a lot of mental translating, f prime increasing translates to, sorry, f double prime increasing translates to where is f prime concave up? Where is this graph right here concave up? Okay, and so where is this graph concave up? I guess we haven't answered that one yet. Thought maybe we had, but I don't see it. Okay, so we'll just look at the graph and figure out where it is concave up. Okay, so this given graph here is concave up, maybe starting at C, right? It's concave down in the beginning, but then concave up from C to E, and then down for a little bit, and then up again starting at G. So C to E, and then G forever, concave up. C to E, and then G forever. Okay, if you want to include the brackets, if you want to include those endpoints with brackets, that's fine with me. Okay, where is, all right, so we just did P, so now we're at Q. So where is F concave up? So we got to do some more translating here. So F concave up means that F double prime is positive. And then we're going to write that in a very particular way. We're going to put parentheses around F prime. Don't quite have enough room to fit that in there. F prime, I think that's good. So where is F prime prime positive? And again, anytime you tell me a first derivative is positive, that means that the original function is increasing. And in fact, I think we have answered that question before. F prime is increasing. Is that somewhere? That's right here. So I don't even have room to write the answer, but we've answered this one already. It's the same as the answer for part I of this problem. So hopefully you're getting the idea here that the goal is to translate the given information until you can read something off of the graph that's given. In this case, it's F prime, so everything on this page needs to get translated to something we can read from the graph of F prime. Okay, that was Q. Moving on to R. Where is F concave down? It's the same deal as with Q. So F concave down means F double prime is negative, and then we put our sneaky parentheses around the only function we are interested in analyzing, and this translates to F prime being decreasing, which I'm sure we've answered up above. It's part J. Okay, S, where is F triple prime equal to 0? Okay, here we go. F triple prime, I will write it this way, equal to 0. I haven't done anything except given myself space to put my sneaky parentheses in. So where is F triple prime equal to 0? That means that the given graph, oopsies, that means that the given graph, which we've been highlighting in turquoise here, that thing, its second derivative is 0. And if you tell me a second derivative of some function is 0, then I would say, hey, that function has points of inflection, or candidates anyway. F prime has points of inflection. Where does F prime have points of inflection? And points of inflection of F prime, we have answered already. It is L. So it's the same answer to L. There's only so many ways that I can, there's only so many different answers that we can give, right? Like F prime is increasing, or it's decreasing, or it's positive, or it's negative, or it's concave up, or it's concave down. It's not a whole heck of a lot else that there is to say about F prime. And so all of these questions really are just boiling down to different ways to ask the same things about F prime. And so really this is about doing this kind of translating that we've been doing. Okay, T. Where are the relative extrema of, I can't even read that. Does it say F double prime? I think that's F double prime, yeah. Okay, where are the relative extrema of F double prime? Okay, let's translate. If you tell me you are sitting at a relative extreme point, that means that the derivative of the point of the function we're talking about is 0, right? If I just said, got some function and there's a relative max, then you would say, oh, probably there's a horizontal tangent line at that relative max. And so we're looking for places where the first derivative of the given function is 0, and the given function in this case is f double prime. And so this is really saying, where is f triple prime equal to 0? Oh, good, we answered this one already. It's S. So you would have to, again, do the same shenanigans we did in part S, but you will get the same answer we got in part S, which we didn't even write down because it was some previous part. I guess it was L again. Okay, moving on to U. What can you say about the sign of f of E? So I can't say anything about the y values of the function f. This one is it cannot be determined. It's the same reason that we wrote that for the first part here. Where is f of x equal to 0? I have no earthly idea. I can't say anything about any y values for f. But I think we can answer these next 3 questions. So what can you say about the sign of f prime of E? So f prime is the given function. We just have to look at it. F prime of E is just this y value right here. Is that a positive, a negative, or 0? Well, it's a negative, right? It's just down below. So this one is negative. I pity anybody that has to look at this PDF after the fact without the accompanying video. Good luck figuring out which answers go with which questions. W, what can you say about the sign of f double prime of E? Okay, I don't know. I got to translate. F double prime of E. Give myself room for my sneaky parentheses. Okay, got it. Now it's saying the derivative of the pictured function is supposed to be 0. The first derivative of the pictured function. I said it's supposed to be 0. That's not what I meant. I meant, what is the sign of the derivative of the pictured function at E? That's what this is asking for. It's saying take the first derivative of the function whose graph is given, look at that first derivative at E, and determine its sign. So the first derivative has to do with slope of tangent line. At the point E, tangent line is going uphill. That means its slope is positive. That means that this is a positive number here. So f double prime of E is some positive number. X, what can you say about the sign of f triple prime of E? Who knows? All right, let's look at this one. F triple prime of E. Again, giving myself space for my sneaky parentheses. Okay, so where are we here? This one. This is really asking about the second derivative of the pictured function. Let's take a look at E, second derivative. Second derivative has to do with concave up or concave down. I'm focusing my attention here. The graph is concave up to the left and concave down to the right. That would mean that the second derivative values are all positive over here, but then the second derivative values are negative for all these concave down spots, which probably means that the second derivative is 0 at E. So that's what we're writing. Not positive, not negative, it is 0 as long as we were really looking at a point of inflection on the graph of f prime. Okay, and then finally, part Y, it says graph f and f double prime on the axes below. Okay, let's try to do this real quick. Okay, to graph f, so we're going to start with f. I'll do this one in blue. So graphing y equals f of x here. So what I'm going to do is look up above for all of the questions that we answered that had to do with f specifically. Okay, so part A had to do with f, but we couldn't answer that one. So parts B and C, those are good ones for us. Part B and C had to do with whether f was increasing or decreasing. And so I'm just going to maybe copy those down below. So I need to do something where f is increasing on A to C and I to infinity, and f decreasing from minus infinity up to A, and then from C to F, I guess. Nope, from C to I. I think that's it. I might have stopped it at F up above for some technical reason. C to F, F to I. Oh yeah, it was supposed to be flat at F. A to C, I to infinity. So I'll just copy it like it was up above. C to F, and then F to infinity. Okay, and then it also talked about in part D here, the points of inflection of F. And I'm looking around to see if there's anything here that talks about the concavity of F. Here we go. That's really what we want, is in question Q. So just scanning around for F questions. So where is F concave up and where is F concave down? So of course I didn't write these answers down because there was no space, but in Q we concluded with F prime being increasing, which was right here. So so Q said F is concave up, and our answer was the same as I. So concave up from minus infinity to B, and then D to F, and then H to infinity. Minus infinity to B. Of course, I can't remember any of that stuff. Minus infinity to B, D to F, and H to infinity. D to F, H to infinity, union there. And then it must be concave down on the remaining intervals. I think that's all we're going to write down for this. So B to D, and then F to H. Okay, so let's put all this together. What we want to do is draw something that is increasing from A to C, and then decreasing until we get to F. It's supposed to be flat, horizontal at F, and then decreasing some more. There's too many infinities here. This must be an I. Let's try this again. Decreasing in the beginning until A, then it's increasing, then it's decreasing. It's actually flat at F, then it's decreasing some more, and then it's increasing the rest of the way. So let's see if we can get a rough first sketch of this thing. So the important numbers here were A and C and F and I. I'm just going to arbitrarily label them here. A, C, where was the, I think 0 was at E. So F and I are to the right. F and I. And so we're just going to get our first very rough sketch of this thing here in red. So decreasing until we get to A. I don't know where it starts. It could be up here, decreasing until A. It could be down here, decreasing until A. Either one is totally okay. There's not enough information to know. Decreasing until we get to A, and then increasing until we get to C. So actually it's got to be flat. Sorry, I'm drawing something too precise. Okay, decreasing until we get to A, increasing until we get to C, decreasing from C to F, then it's flat at F, but then it keeps decreasing some more. Decreasing from C to F, I'm going to put like a little horizontal blip there just to tell me that it's flat there, but then it keeps decreasing until we get to I, and then increasing from I to infinity. So that is a very rough sketch. The only thing I need to do now is tack on the concavity. So concave up until we get to B. Here we go. Concave up until we get to B. Oh, so we got to mark B on our picture now. So B is here. What's the other point of inflection? We've got concave up, D, F, H. All right, so we'll put D here. F is already there. H is here. Okay, great. So like we said, we wanted F to be concave up until we get to B. So we're just going to curve this thing out. Concave up until we get to B. So it's got to be concave up and decreasing, and then concave up and increasing until we get to B, right above B. And then it's supposed to be concave down from B to D. So let's do that. Concave down from B to D. Concave down increasing until we get up to the top there, and then concave down decreasing until we get to D. Okay, what happens at D? From D to F, the function is concave up. So let's draw something concave up, but still decreasing. Oops, wrong color there. Concave up, but still decreasing. Now I've got this little bloop here, this flat thing, so it's got to be flat. I'll try that one more time. Concave up, decreasing, but flattening out there at F. And then what happens at F? So at F, we're now going to be from F to H concave down until we get to H. And then what happens at H? Concave up forever. So we're going to go concave up starting here, but then it's, try that again, concave up here, but then it reaches a min somewhere up above or below that thing, and then concave up, increasing the rest of the way. Oh my goodness, that was tough, 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 tough. So, so I'll erase as much as I can of this red thing, but I really do think that it is too much to ask to try to do it all in one shot. I like the rough first attempt with just straight lines increasing or decreasing, and then smooth it out with the concavity once you've got your basic shell. Okay, so this is my graph of y equals f of x. If you had a vertical shift of this, you can move it up or down any amount, totally fine. No way to know where this thing starts or ends, but we should be able to capture the increasing, decreasing nature as well as the concavity. Okay, goodness, I guess we got to do one more of these things here. So f double prime, we're going to do that on the graph at the right. And so now I'm just going to take my quick glance here and see if there's anything here about f double prime increasing, decreasing, or f double prime concave up, concave down. Okay, I see some information. Let me erase some stuff here. So I see information about f double prime. Where is it? F double prime is, I saw it, where'd it go? F double prime is increasing. It's that question. And then does it say anything about f double prime being concave up or concave down? Okay, so I didn't see anything here about f double prime being concave up or concave down, but I do see that I've got information about f prime being positive here, f prime being 0 here, sorry, I've been saying prime, but I meant double prime, being positive, 0, and negative. And then I guess we still have to do work to figure out about where it's concave up, where f double prime is concave up or concave down. Maybe, I don't know. Let's just see if we can get a real rough sketch here. Okay, so let's start with the places where f double prime is 0. So that turned out to be at B, D, F, and H. Great, that's a good start. I'll go ahead and label this thing with all of our letters. A, B, C, D. I think E was right. E was there at on the y-axis. F, G, H, I, and we'll put J right there. Okay, so one more time. F double prime is 0 at B, D, F, and H. B, D, F, H. B, D, F, H. So those are the 4 x-intercepts of this graph. And then it says that F double prime is positive. I'm looking right up here. And we did some translating. I think the answer is just off the screen here. We said F double prime is positive on these intervals. So until B, and then D to F, and then starting at H. Until B, D to F, and then from H onward. So real rough sketch, positive. Until B, D to F, D to F, and then from H onwards. So I'm just drawing positive straight things. I don't have my concavity quite down yet, but I know I've got to hit those x-intercepts and I've got to be positive on those intervals. I'm guessing it's got to be negative on the other ones. Let's make sure. F double prime negative, B to D, and F to H. So hopefully that jives. B to D negative, B to D negative, great, and then F to H. Hey, that works out really well. So I think that's fine. I mean, like we've got I guess we could analyze further, you know, to figure out like the concavity or exactly where the maxes and mins are. And you are welcome to dig into this a little bit further if you wish. I think I'm just going to smooth this out and call it a day. I'm going to draw something that roughly follows these straight lines that I've got. Maybe the min is down there around C, maybe the max is at E, maybe the min is at G, something like that. It's possible I have some of my concavities not quite right, but to be honest, like if there's a point of inflection, I don't know, like if there's a point of inflection like someplace in between, you know, F and G, like if there's a point of inflection there, like we wouldn't know about it, right? Because the only points that we have any kind of analysis on are the labeled points, the ones with these letters on them. So I think I'm okay with the blue curvy thing that I've got there. But like I said, if you want to dig in a little bit more, you can feel free. But I don't want to spend any more time on this. I'm actually overdue for lunch for a while now, so I'm going to go eat. But it sure feels like probably if there's a min someplace between B and D, it's probably at C. And I think you could analyze the graph of F prime given above to really confirm that that's the case. But I'm going to go eat, so we're going to call this video a day. Good luck studying, and we'll see you at the test.